In this lesson, we will do some examples to illustrate the concept of average speed and average velocity. I really just want you to understand the fundamental meaning of what these two terms are. Speed is how fast an object moves. Velocity is how fast an object moves in a particular direction. So we can obviously conclude that speed or velocity is speed plus direction. Now, average speed is the total distance covered in a given time interval, while average velocity is the total displacement of an object divided by the total time taken. Now, velocity is a vector quantity, while speed is a scalar quantity. Now, in front of us, we have Tom and Jerry, and they are about to take part in a race. Obviously, from what you can look at, Jerry is weighs more than Tom. So obviously, what we expect is that he will take a longer time to cover a smaller distance, to cover the same distance, sorry. So let's go. So they've competed in the race. So what we will do is, I would like for us to plot the position of Tom and Jerry with respect to time on a graph, to compare the two graphs to see which one actually runs at a faster speed. We already know the answer, but we want to see from our graphs. So in this diagram, we've plotted the position of Tom and Jerry versus time. The blue graph represents Jerry and the red graph represents Tom. So what we are going to do is calculate the slope of each graph. Now, the slope of a graph is just the change of the quantity in the y-axis divided by the change in the quantity in the x-axis, which means that the slope of a position versus time graph is just the change in position divided by the change in time. In other words, the slope of a position versus time graph, as long as the graph is a straight line, signifies average velocity. So we know that by definition, average velocity, V average bar, is the change in the position divided by the change in time. So let's calculate the average velocity for Tom, and let's calculate the average velocity for Jerry. If we look at this graph, we are going to pick 2 points. So this is normally x final minus x initial divided by t final minus t initial. You have x final minus x initial, t final minus t initial. I'm going to put this in brackets, and then I'm going to add an I hat here because they are moving along the x direction. So we will have here, let's pick, if we pick the final position for Tom and Jerry, we will have, let's pick 2 and 8. So we have 1.5 and 7.6. So this is 2 and 8. So this is 8 meters minus 2 meters, all divided by 7.6 seconds minus 1.5 seconds. So we have here 8 meters minus 2 meters divided by. So for Tom, this will be 1 and 4. So this is 4 seconds minus 1 seconds. So this will be equal to 6 meters divided by 3 seconds. That will give us 2 meters per second. So if we do the calculations for Tom, we have 6 divided by 7.6 minus 1.5. That gives us 6.1. So 6 divided by 6.1, this will give us 0.98 meters per second. So obviously you can see that the average velocity for Tom is greater than the average velocity for Jerry, as clearly illustrated from our graphs. Now, so keep in mind before we proceed that average velocity is equal to the slope of the position versus time graph for a straight line. This is important. This is very important. So the next example here, we have two guys, one on a mini car, and the other on a bicycle. They are initially a distance d apart from each other, and d is equal to 150 meters. They start moving at the same time. So the question would be, where will they bypass each other? Now, if we play back the video again and watch, they bypass each other around here. That's where they bypass each other. At that time, let's say that A had traveled a distance x from where he is to this particular point. Then B will travel a distance d minus x. We know that average velocity is just the change in x divided by the change in time, which implies that v of A is the change in x of A divided by the change in time, which is going to be equal to x minus 0 all divided by the change in time, which is just t minus 0. So this is x divided by t. Similarly, v of B is just delta x of B divided by delta t, which is going to be equal to d minus x Remember that B is moving to the left and A is moving to the right. So technically this is going to be negative bracket x minus d divided by t minus 0, which is going to be d minus x all divided by t. So the question is, where will they bypass each other? It's a question of time. We need to calculate where, which is the question of, we need to calculate x. So what we can do is, from this equation, you see that x is equal to v of A multiplied by t. From this equation, you will see that d minus x is equal to v of B multiplied by t. This would mean that x is equal to d minus vbt, but we are looking for x. So what we can do is, the only unknown in this equation is t. We know d, we know v's of b, but we don't know t. This is equation 1, and this is equation 2. So let's write down equation 1 and equation 2. Equation 1, you have x equal to VAT. Equation 2, you have x equal to d minus vbt. So you would realize that from equation 1, t will be equal to x divided by VA. All we can do is substitute the value of t in equation 2, which therefore will become, which would mean that x is equal to d minus VB bracket x divided by VA. Our question is to look for x, so we need to take all the terms that contain x So the question is for us to look for x. So we need to take the terms that contain x to one side of the equation and the rest to the other side of the equation. So if we do that, we will have here, this is the same as d minus vb divided by va multiplied by x, which would mean that x plus vb over va x will be equal to d. If we factorize out x, we will have here x bracket 1 plus vb divided by va. All of this should be equal to d. In other words, x is equal to d divided by 1 plus vb divided by va. This is the expression for x. But what is d? D is 150 meters. What is VA? 5.5. And what is VB? 10. So this will be 150 meters divided by 1 plus 10 meters per second divided by 5.5 meters per second. And we can calculate our answer. 10 divided by 5.5, that gives us 1.8, plus 1, 2.82. So 150 divided by 2.82, that will give us 53.2 meters. 53.2 meters. In other words, they bypass each other 53.2 meters from the origin. This is a beautiful problem.